So good afternoon to my lecturers. So this is the lab for the lab 3, which is the Fourier series, and for the Fourier series and the LTI system. So what we can see that is for the exercise 1, which is use the definition to equation to find the DTFS coefficient, which to evaluate the 100 point of DTFS of the following signal. So how can we do this? So we'll be doing it by let the n equal to 100, which n equal to 0 and n minus 1. So for the equation for the W1, so W1 is the cos, which is 8 pi over 21. So for the W2 is for the pi over 3. So this is the equation which is given in the question. So which is inside the equation of the cosine. So for the yn is the combination of S1n and S2n. So when we do this equation, we will have two figures, which is figure 1 and figure 2. So figure 1 is the with the cosine of dt waveform signal, and for the figure 2 is the cosine of DTFS waveform signal. So this is the signal that we get from our equation and with our coding. So let's proceed to the second question. So the second question will be n equal to 100. Just only the equation will change, which W1 is equal to 10 times the pi divided by 19, and the second equation is 4 times pi divided by 19. So for x1n is 2 sine W1n, and S2n is the second equation, which is cos W2 times n. So for yn, same thing, is the combination of S1n and S2n. So same thing, it will have two figures also. So for the first figure is the cosine dt waveform, and the second is the DTFS waveform. So how we will get is for the cosine dt waveform signal, we'll have positive and negative. So the maximum is 3 and the minimum is -3. So for the DTFS waveform, we'll see is a fluctuating for 100, and the FK is also 100. So let's proceed to the third question. So the third question is also the same. So we will just directly see the result. So the result is all of it is for the DT waveform is from 0 to 4, which all are positive. And for the DTFS waveform, only few signal will have the result, which is 0, 25, and 75. So for the other signal is equal to 0. So let's proceed to the next question. So for the next question is same thing, t equal to 100. It asks us to find the DTFS waveform signal. So which t will equal to 0 to 0.1 and t minus 1. So this we will use this as our interval for 0 to 100. So same thing is the combination of this is the combination of S1 and S2. So this will have a two figure, which is figure 1 and figure 2. So as it says is DTFS. So For the figure 1 is the cosine CT waveform, and the circle is the cosine CTFS waveform signal. So let's see the result. So for the result, it is for the CT waveform, it's just like the waveform of our just like we go for the sound signal. So we will have the waveform which we can get the signal. So for the CTFS waveform, same thing, just that it is a duplicate at the same value of x-axis, and the highest is 460 estimately. So let's proceed to the last question. So for the last question is same thing, is t equal to 100, just like just that I change it to n equal to 100, and n equal to 0 and minus 1. So for w1 is pi divided by 5, and the second equation is the pi divided by 10. So for S1n is cos, and S2n is also cos for the W2. So you also have the two figure, which is figure 1 and figure 2. So let's see the result. So the result that we get is as shown. So it will have positive and negative, just like the DT waveform. So like before the question before, so as for the TTFS, just that the TTFS is have 4 signal, so which is 5, 10, and 90 and 95. So this is the all the result for the lab 3. So I think that's all from me. Thank you.